Hello, everybody. How much time you have been confused by the question what a blockchain is, what it means. It is a new generation of technology and data. Not every brain has ability to recognize how it works. It is new period of evolution. And in this episode we will try to get it clear. Let's get started. What blockchain is? Blockchain is a technology that enables the secure sharing of information. A blockchain is a type of distributed database or ledger, one of today's top tech trends, which means the power to update a blockchain is distributed between the nodes, or participants, of a public or private computer network. This is known as distributed ledger technology, or DLT. Nodes are incentivized with digital tokens or currency to make updates to blockchains. Blockchain allows for the permanent, immutable, and transparent recording of data and transactions. This, in turn, makes it possible to exchange anything that is value, whether that is a physical item or something less tangible. A blockchain has three central attributes. First, a blockchain database must be cryptographically secure. That means in order to access or add data on the database, you need two cryptographic keys. A public key, which is basically the address in the database, and the private key, which is a personal key that must be authenticated by the network. Next, a blockchain is a digital log or database of transactions, meaning it happens fully online. And finally, a blockchain is a database that is shared across a public or private network. One of the most well-known public blockchain networks is the Bitcoin blockchain. Anyone can open a Bitcoin wallet or become a node on the network. Other blockchains may be private networks. How does blockchain work? When data on a blockchain is accessed or altered, the record is stored in a block alongside the records of other transactions. Stored transactions are encrypted via unique, unchangeable hashes, such as those created with the SHA-256 algorithm. New data blocks don't overwrite old ones, they are appended together so that any changes can be monitored. And since all transactions are encrypted, records are immutable, so any changes to the ledger can be recognized by the network and rejected. These blocks of encrypted data are permanently chained to one another, and transactions are recorded sequentially and indefinitely, creating a perfect audit history that allows visibility into past versions of the blockchain. What is proof of work? Most public blockchains arrive at consensus by either a proof-of-work or proof-of-stake system. In a proof-of-work system, the first node, or participant, to verify a new data addition or transaction on the digital ledger receives a certain number of tokens as a reward. To complete the verification process, the participant, or miner, must solve a cryptographic question. The first miner who solves the puzzle is awarded the tokens. It also can be a pool of miners that try to solve this puzzle, and the reward is shared equally. The biggest disadvantage of proof-of-work mining are the high consumption of electricity and equipment. What is proof-of-stake? Under proof-of-work, it kept blockchain secure. Proof-of-stake changes the way blocks are verified using the machines of coin owners, so there doesn't need to be as much computational work done. The owners offer their coins as collateral, staking, for the chance to validate blocks and then become validators. Validators are selected randomly to confirm transactions and validate block information. This system randomizes who gets to collect fees rather than using a competitive rewards-based mechanism like proof-of-work. To become a validator, a coin owner must stake a specific amount of coins. For instance, Ethereum requires 32 ETH to be staked before a user can become a validator. Blocks are validated by more than one validator, and when a specific number of the validators verify that the block is accurate, it is finalized and closed. Proof of stake is designed to reduce network congestion and environmental sustainability concerns surrounding the proof-of-work protocol. Difference between proof-of-work and proof-of-stake. Proof-of-work concepts. Block creators are called miners. Participants must buy equipment and energy to become a miner. Not energy efficient. Robust security due to expensive upfront requirement. Miners receive block rewards. Proof-of-stake concepts. Block creators are called validators. Participants must own coins or tokens to become a validator. Energy efficient. Security through community control. Validators receive transactions fees as rewards. What else can blockchain be used for? Cryptocurrency is only the tip of the iceberg. Use cases for blockchain are expanding rapidly beyond person-to-person exchanges, especially as blockchain is paired with other emerging technology. Examples of other blockchain use cases include the following. Databases of intellectual property. Property rights or ownerships. Blockchain supports smart contracts, which are programs that trigger transactions automatically upon fulfillment of contract criteria. It was the main theoretical information about blockchain. Links to the useful articles I will leave in the description. Let's deep into Python code to create a simple blockchain application. Our simple blockchain app contains two main functions, analyze and create blockchain web app. The first function analyzes the code and creates an object model of it based on Python's standard classes and modules. The second function creates a Flask web application based on this object model and stores all of the data needed to create a blockchain in it, including the digital fingerprints for each block. The code begins by importing the necessary libraries. The hashlib library is used to calculate a digital fingerprint for each block in the blockchain. This fingerprint is then stored in a variable called hash. Create a blockchain class. The code creates a Python program that will create a blockchain. The code first imports the necessary libraries that we have done earlier for creating a blockchain. Next, it calculates the hash to add digital fingerprints to the blocks. Finally, it stores data in the blockchain using JSON. The code starts by creating an empty list called self.chain. The code then creates a function called createBlock, which takes two arguments, proof and previous hash. The createBlock function first calculates the index of the block in the chain, that is, it adds 1 to the value of length self.chain. Then it sets the timestamp to now, and stores the proof and previous hash values for this block and block variables. Finally, self.chain is updated with this new block object. Next, the code creates a function called printPreviousBlock that prints out the contents of self.chain with -1 index, which is currently set to be equal to length self.chain plus 1. Now let's take a look at how these functions work together. When you call createBlock, you provide it with two arguments, proof and previous hash, which are both Python objects. This tells createBlock what data should be stored inside of its block variable, proof and previous hash, as well. The code first creates an empty list called self.chain. Next, it creates a function called createBlock which takes in two arguments, proof and previous hash. The purpose of this function is to create a new block on the blockchain and store its information within the block object. The next part of the code is responsible for displaying the previous block on the screen. This is done by using the printPreviousBlock function which takes in one argument, self.chain with -1 index. Finally, the last part of this code is responsible for performing proof of work. The proof of work function is used to create new blocks in a blockchain network. It is a cryptographic algorithm that requires solving a difficult problem in order to generate a new block. The difficulty of this problem is adjusted so that it will take an average amount of time to generate a new block, regardless of how many people are mining on the network at any given time. The additional functions. Hash. That encodes block and return its hash. And chain valid. That check a chain is valid or not. Next, the data needed to create a blockchain web app is imported. This includes the Flask web application framework. The code starts by creating the app, some configs and instance of the class blockchain. This class stores information about the blockchain, including the previous block and proof. This class contains all the information about a blockchain, such as its length, index, and proof. Let's get started with creating a route function of the application that returns a string. Run the application in the local host and port 5000. Open in browser to check that it works well. The code then uses the proof of work function to create a new block. The new block has a proof and hash that are based on the previous block and proof. Finally, The code prints out the current state of the blockchain and returns the URL for accessing it. Next, the code checks to see if the blockchain is valid. If it is valid, the code returns a response with a message that says, "The blockchain is valid." Otherwise, the code returns a response with a message that says the blockchain is not valid. Finally, the code displays the blockchain in JSON format on screen using the display chain method. The code will display the blockchain in JSON format. Run the application. The code creates a new block on the blockchain. This block contains the proof of work done by the current miner, as well as the previous block's hash. The miner then prints this block to the console and stores it in a variable called previous block. Next, they use proof of work to create a new hash for the new block. Finally, they store this hash in a variable called previous proof and set the value of proof to be equal to this newly generated hash. Check the display chain address. It shows the first initial block in all blocks that we have mined. And call the valid address. We can see that the chain is valid. Thank you for watching. Please, give a like for support this channel. Write comments, share with friends, and subscribe to see new series. Be safe. Bye.